All right, today we are going to be talking about measures of dispersion. So we're leading down the path to get to standard deviation, but not quite there yet. We've already talked about mean, median, and mode, and today we're going to continue our discussion starting with range. So the range is the difference between the highest value and lowest value of a set of data. So the difference between the highest value and lowest value of a set of data. Okay, so we have ages of students on the basketball team. So the youngest to the oldest is, for the first one, the range is equal to 2. 17 minus 15, 2. For the second set of data, we have ages of students in a community tutoring program, 6 to 18, so the range is 18 minus 6, which is 12. All right, so the range can tell us some stuff about our data. The median can tell us some information about our data, the mean, but I'm going to compare why we need something else today. So let's first take a look here at Example 3. The range is dependent on only the largest data value and the smallest data value. Therefore, the range can be very misleading. So consider the following sets of data. So we have ages of people on a golf course. So let's take and place these on this line here. I'm going to put 10 at the lowest point, and then count to 24, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 27, 25, 26, 27, 28, 29, 30, 31, running out of room there, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, right at the very end. Okay, perfect. So now, if you take all those numbers, add them up, and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, you get a mean of 30. You're just going to trust me on that. I'm telling you it is indeed 30. If you take 9 for the median, if you take 9 plus 1 and divide by 2, it's the fifth number in. So 1, 2, 3, 4, 5. Oh, the median is also 30. And the range is 50 minus 10, or 40. Okay, so now what does that tell you about the data? Does it tell you, it looks like the data is kind of grouped in the middle. The fact that the mean and the median are the same, does that indicate that? With the range of 40, maybe, maybe not. Let's take a look at ages of people at a musical. So I'm going to do the same thing. It goes 10 to 50, so let's place the 10 there, the 12 there, 16, 24, 5, 6, 7, 8, 9, 30, 36, It's much easier to gather some information. This is how you would do a box and whisker. If we put it spread out like this, 9, 40, 1, 2, 3, 44, 45, 6, 7, 8, 9, 50. I know I've done it correctly. Okay. So, if you compare this number graph to the ages of people on the golf course, these are ages of people at a musical, when you add those up again and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, same thing, you still get a mean of 30. And again, it would be the fifth number in, which is 30. The median is the same. And the range is 50 minus 10 or 40. So if you were to compare these two data sets, you might say they're identical. But if you look at them on the number line, they are not identical. So it's not always useful to use mean, median, and range to determine some information about whether the data is spread out or closer together, because some of those things might help you with making predictions for future things. So that's why we're kind of leading into, for tomorrow, we'll be talking about standard deviation. So interquartile range, okay. So interquartile range is going to give us a little bit more information. Let me just go back a second, make sure I got everything. Ah, there we go. There was something at the bottom that I missed. Oh, guess not. Ah, there we go. Yes. Are the data sets different? Yes. I would say that the musical ages are more spread out. Can you tell that, though, from the medians, means, and range? No, they are all the same. So that brings us to another form of dispersion, which is the interquartile range. The interquartile range depends on the first and third quartiles. The interquartile range, as I like to go, the IQR equals quartile 3 minus quartile 1. So it depends on those first and third quartiles. Now, we saw those in the calculator the other day. You can also get them without. Let me give you a little more information, though, first. The interquartile range tells the range of at least 50% of the data. It better represents the spread of the data. So go back to exercise 3 and find the interquartile range for each set of data. So I'm going to go back and do that. Okay, so the ages of people on a golf course. So what you want to do is consider this as your median right here at 30. And you want to find the third quartile and the first quartile. You need to take the remaining 4 pieces of data and find the median of that. So the interquartile range would be right here between 24 and 27. I'm sorry, the median of this set of data, or quartile 1. So we're trying to take this data and divide it into fourths. So this, if you take 24 plus 27 and divide it by 2, you end up getting 25.5. Okay, so that is quartile number 1. All right, so, and then if we go to the right-hand side, and we are going to take and find the median of those 4 data values, we would be doing 33 plus 36 divided by 2, and that is 34.5. That's quartile 3. So 30 is actually quartile 2, or the median. And then you have quartile 1, which is 25.5, and quartile 3, which is 34.5. And then you could make a box and whisker plot out of this. So at 24, here's 25.5 right here. And then draw down at the median 30. And then go to 34.5, which is right here. So you draw a box. And then a whisker goes out to the 10 and goes out to the 50. So here's quartile 1, here's the median, and here's quartile 3. And then that gives you a little bit of idea of, where most of the data is within that box. And if you take a look at the interquartile range, so then we'll calculate the interquartile range. So the interquartile range here is going to be quarter 3 minus quarter 1. Well, quarter 3 is 34.5, and quartile 1 was 25.5. So the interquartile range is 9. All right, now ages of people at a musical. All right, so for this one, again, the median is here at 30. This is the median. Again, if I take the data points to the left, I'm looking for this value here for the ages of people at a musical, and that is 14, and that's quartile 1. So at 14, we have quartile 1. A little bit more spread out. And then if you take a look at the right-hand side of the data, the median of that data is right here. That's quartile number 3, and that is 46. So at 46, here's the rest of my box, and then it goes to 50. So that interquartile range tells the range of at least 50% of the data. So tells you that it's a little bit more spread out. That interquartile range of this one, so the interquartile range, would be 46. So it's quartile 3 minus quartile 1. So it's 46 minus 14, which is 32. So the larger the interquartile range, the more spread out, because 50% of the data lies in that range. So if we just looked at this on the previous page, okay, it was easier to just go back there. Okay, so ages of member of a book club, find the first quartile, median, third quartile, interquartile range, make a box and whisker plot of the data. All right, you can get the first quartile, third quartile, median on the calculator like we did the other day. We'll practice that in a second. But first, let's do it by hand. So I'm going to put the 21 down here, 2, 2, 3, and the 24 and the 25, 27, 28, 29, 30, 31, 2, 3, 34, 35. I've got 2 at 35. Okay, and then 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71. So I think I counted that right. That's 71. So to take and find the median, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for the median, I'm going to do 13 plus 1 divided by 2, so 14 divided by 2, so the median is at the 7th number. So 1, 2, 3, 4, 5, 6, so right there. 1, 2, 3, 4, 5, 6. I'm sorry, it's at the 7th number. 1, 2, 3, 4, 5, 6, the 7th number. I said 6 and I circled it. 1, 2, 3, 4, 5, 6, 7. 7th number. So that's 35. Okay? So you draw a line through the 35. And that gives you your median. And then to find our first quartile, I'm going to just look at this data here and find the median of that. So it looks like the median is going to be, of those, this is quartile 1, which is 26. So quartile 1 is the average of 25 and 27, which is 26. So at 26, here I have the second part of my box. So this is quartile 1, and this is the median. And then I'm going to take the last bit of data and find the median quartile 3, which would be right, I believe, in here. So that's 39.5. So quartile 3 is 39.5. So finding 39.5, there's right here. So there's quartile 3. And then if you just extend out, it tells you where the quartile, inner quartile range there between quartile 1 and quartile 3 tells you where most of the data is centered. So quartile 3 was equal to 39 plus 40 divided by 2, which was 39.5. And then the inner quartile range is equal to quartile 3 minus quartile 1, which is 39.5 minus 26, which is 13.5. Okay? So you can get this information from the calculator. Again, if you go to Stat and Edit, and you enter it all into L1, and then you go to Stat Calc, and you click 1 bar Stats, and you tell it your information's in L1, and then it will list the quartile 1, the median, and quartile 3. I'm not going to do that. It's pretty easy to do. Okay. So that was that. We did all that. The 71 presents an interesting problem. It's an outlier. You can see that it's like out there on its own. An outlier is a data value that is greater than the upper quartile, okay, the upper quartile, which is also referred to as the third quartile, okay, plus 1.5 times the inner quartile range. Or less than the lower quartile, which is quartile number 1, minus, okay, so we have some keywords, minus, plus 1.5 times the inner quartile range. So that little asterisk means times. Okay, so calculate the outlier range for exercise number 4, which was, I believe, the ages of members from the book club. So the outlier is going to be greater than, okay, because it's on the outside of the third quartile, it's going to be greater than. If it was less than that first quartile, we'd use the less than. So it's greater than the upper quartile, which is quartile 3, plus 1.5 times that inner quartile range. So the outlier is greater than. Now quartile 3 was 35, and that inner quartile range was 13.5. So this tells you which data values would be outliers. So your outlier would be greater than 55.25. So we say therefore 71 is an outlier. And then you can use the graphing calculator to graph a box and whisker as well. And I believe that those are your steps for you. I don't think that you're going to be asked that on the Regents exam, but if you're interested, it's there. And I believe that's it. Have a good night.